there, Miss Aselson here. We're working on probability notes, the addition rule. And the first thing you need to know about when you have an addition rule or probability with addition is you're not just going to add, but you're going to go ahead and add and subtract. So in this first line, let's put add and subtract. So if you see this keyword or in your word problem, you're always going to set your problems up like this. So what this really means is the probability, P means probability, of one thing happening, and I'm going to choose A as my letter for whatever thing it is, plus the probability of B. So this is a separate thing. So maybe the first one I'm looking at green, and the second one I'm looking at something that's blue, the probability of green and the probability of blue. And then you're going to subtract out the probability of both. Okay, so you have to think, can something be both green and blue? And I'll get into this a little bit more as we go. So don't worry if you're not understanding quite yet. You'll get this in a minute. Okay, you have mutually exclusive versus mutually inclusive. If it's exclusive, they do not affect or impact each other. But if they're inclusive, think if you include somebody, they're doing it with you, so they do affect or impact each other. So let's just read a couple of these and see if they're mutually exclusive or inclusive. So drawing a heart or a diamond from a standard deck of cards. So if you want to look at your standard deck of cards there and look, how many have hearts? Look at the row that has hearts and look at the row that has diamonds. Do any of the hearts have diamonds, or do any of the diamonds have hearts? The answer would be no. So they would be exclusive. They're not the same card. Okay, so let's look at number 2. Drawing an ace or a spade from a standard deck of cards. So look at your deck of cards, find the aces. So you have 4 of those, and then your spades are kind of the upside down shovel looking ones. They're black, so look at the black upside down shovel looking one. Okay, so look at those. Are there any aces that also have a spade on them, or any spades that also have an ace on them? Yes, you have an ace of spades, so this would be inclusive. Okay, number 3 says rolling a 5 or a number greater than 3. Whenever it's talking about rolling, assume they're talking about rolling a die or a dice. Okay, so you're rolling a 5 or a number greater than 3. Well, you have to think, is 5 a number greater than 3? It is, so that's going to be inclusive because they do affect each other. Okay, and the last one, picking a red or a blue M&M out of a bag of M&Ms. Okay, so when I'm picking a red or a blue M&M, I'm thinking, can I be red and blue at the same time? Well, you can't. So that's going to be mutually exclusive because either you're a red M&M or you're a blue M&M, but you can't be both. Okay, so let's try some of these in word problems. Okay, it says a bag contains 8 red marbles, 12 blue marbles, 9 yellow marbles, and 11 green marbles. A marble is drawn at random. Find the probability that the marble drawn is either blue or green. So let's go back to the start. I have to find the total. So if I have 8 red, 12 blue, 9 yellow, and 11 green, I'm going to add all those together, and my total number of marbles is 40. I have 40 marbles. Okay? If you draw a marble at random, they want you to know, or they want you to find the probability if the marble is either blue, and then here's my keyword or. When you see the keyword or, that tells you that you're going to have to both add and subtract. So you're going to get your line set up just like this. So you have addition and you have subtraction. Before we worked on probability and we used the word and told us to multiply. Well, now we're given the word or, and or tells us we're going to either add or subtract. The great thing about this is you never have to think about your bottom number. Whatever your total is, your bottom's going to be the same all the way through because when you add and subtract fractions, the bottom number has to be the same. Your denominator has to be the same. So I'm just going to look at my word or, and I'm going to see what words are on either side. So the first word is blue, so I want this one to have blue. And the next word is green, so I want this one to have green. This third line is, you're going to look at it and say, can it be both? So now I'm going to go back up into my reading, and it says I want the blue one. So I'm going to look, and I see right here I have 12 blue marbles. So my first line is going to be 12. The next thing I'm going to look for are green ones, and this one says I have 11 green marbles. So this one under green is going to be 11. And then I have to think to myself, can I be a green and a blue marble at the same time? Well, no, you can't be green and blue at the same time. So that's going to be a 0. If I add 12 plus 11, I get 23. And then I want to go ahead and divide those out. So 23 divided by 40 is 0.575. Okay, just like before, we're going to round to our hundredths place right there. So I'm going to keep my 0 the same. The 5 is going to be the same. This 5 is going to tell that 7, you're either going to stay a 7 or you're going to move up to an 8. If it's 5 or above, I give it a shove, so it's going to move up to an 8. So I'm going to make that one an 8. Okay, now I have to decide if it's inclusive or exclusive. I can look at this number right here. If that number is a 0, that's going to be exclusive because they do not impact each other. So if it's a 0, it's going to be exclusive. So we would just circle that one. If it was any number other than 0, it would be inclusive. Okay, let's try another one. Okay, and this one says there are 84 teachers at Farmington High School. So right away, I know my total. My total is 84. That's going to be my bottom number. And then it goes on and says there are 12 math teachers, 14 science teachers. Find the probability that the teacher chosen for the commencement speech is either math or, there's my keyword, or science. So right away when I see or, I'm going to do this plus this minus this equals this. I can always, when I add and subtract, get my denominator in there right away. And I'm going to carry that all the way through. Okay, then I'm going to look at either side of my or. And this one says math. And this one says science. Okay, when I look, it says there are 12 math teachers. So I'm going to put my 12 right here. And then this says there are 14 science teachers. So I'm going to put my 14 right here. And remember, this line is both. So think about it. Does your math teacher go in and teach you science? The answer is no. The math teacher does not teach science, and the science teacher does not teach you math. So they're not both. You're either going to have a math degree or you're going to have a science degree, but you're likely not going to have both. Okay, so then we're going to add those together, our 12 and our 14, and I get 26. And if I take 26 and I divide it by 84, that's going to give me 0.309. Here's my hundredths place, so I know I'm going to keep the 0, the decimal, the 3 is going to be the same. This 9 is going to tell that 0, because it's 5 or above, it's going to give it a shove, and it's going to turn it to a 1. Okay, the next thing I'm looking at is this number right here. Because it's a 0, it's going to be exclusive, so I'm just going to circle exclusive. Okay, let's try another one. Suppose that out of 1,400 students, so I know right away my total is 1,400. And then it says 550 take Spanish, 700 take biology, and 400 take both Spanish and biology. What is the probability that a student selected at random takes Spanish or biology? Okay, there's my keyword or. So I'm going to do this plus that minus this equals this. I know my bottom number is going to be 1,400 all the way through. So I'm just going to go ahead and put those all the way through. Okay, I'm going to look at either side of my or. So my first or is Spanish. And my second one is biology. And then my third one is, can you have biology and Spanish in your schedule? Okay, so I'm going to go back up. The first thing I'm looking for is Spanish, and it says 550 take Spanish. So this first one's going to be 550. Okay, the next one it's asking about is biology. So let's read about biology, and it says 700 take biology. So this one's going to be 700. And then it wants to know, can you have both Spanish and biology in your schedule? Well, right here it says 400 take both, and that both, well, it even goes on to say Spanish and biology. So yes, you can have Spanish and biology in your schedule. So I'm going to put that 400 in the spot that says both. So if I take 550, I add 700, and I subtract 400, I get 850. Now I'm going to take 850 and divide it by 1400, and I get 0.607. Here's my hundredths. So 0.6 stays the same. This 7, it's 5 or above, so I'm going to give it a shove. So I'm going to make this one a 1. Okay, now we're going to decide if it's inclusive or exclusive. So I'm looking at this number right there. It is not a 0, so because it is not a 0, it's going to be inclusive. You're including them. Okay, number 8 says there are 4 algebra books, 3 literature books, and 2 biology books on a shelf. Okay, it doesn't give us our total, so we're going to take those numbers and we're going to add them together, and that's going to give us our total number of books. So when I add 4 and 3 and 2, I'm getting 9 books. If a book is selected at random, what's the probability of selecting a literature book? And then I have this keyword or an algebra book. Okay, or tells me I'm doing this plus this minus this equals this. My total goes on the bottom, so 9, 9, 9, 9. Okay, I'm going to look at on either side of my or. So this one I want a lit book, and this side I want an algebra book, and then this one is both. Okay, the first one is literature, so it says there's 3 literature books. The next one says there's algebra, and there's 4 algebra books. And now I have to decide, can I be a literature book and an algebra book at the same time? So think about it. Do you ever bring your English book into math and do math with it? Or do you ever take your math homework in English and turn that in for an assignment? No, you wouldn't do that. So it cannot be both, so I'm going to put a 0 right there. So if I add those together, 4 plus 3 is 7. 7 divided by 9, I get 0.777. This is my tenths place. Sorry, not my tenths, my hundredths. And that one's going to tell me what to do. Remember, we keep our 0 and our first number the same. And that number after our 7 in our hundredths place, 7 or above, or sorry, 5 or above, I'm going to give it a shove. So I'm going to turn it to an 8. Okay, then I go back to my both category. And I have a 0, so because it's a 0, it's going to be exclusive. Number 9, a card is drawn from a standard deck of cards. What is the probability of drawing an ace or a red card? So on these ones, we got to think about our total. So if we have a standard deck of cards, our total is always 52. There are 52 cards in a deck. Okay, so I'm going to have this plus this minus this equals this. And 52 is going to be the bottom number. Okay, I'm looking on either side. I need an ace. And I want any red card. And then can it be both? Okay, so looking on my deck of cards, aces, there are 4 aces on a deck. Red cards, I have 2 rows of red cards. There's 13 in each row, so there's going to be 26 red cards. And then, can you have an ace and be red at the same time? Yes, there are 2 aces that are red, so I'm going to put that 2 right there. This is going to bring me to 28. I'm going to take 28 divided by 52, and I get 0.538. Here is my hundredths. My 0 stays the same, my 5 stays the same. This 8 is going to tell that 3. It's 5 or above, so I'm going to, that 8 is 5 or above, so I'm going to give that 3 a shove to a 4. Okay, now I'm going to go back and I'm going to look and see, do I have a number here? Yes, I do. So it's going to be inclusive. All right, last one. There are 100 students that participate in spring sports. So I know right away my total is 100. So my bottom number is going to be 100. 15 students participate in track, 14 participate in softball, and there are 2 that participate in both track and softball. What's the probability of getting a student that participates in track, and then here's my keyword, or softball? Okay, or tells me I want this plus this minus this equals this. Okay, so I'm looking at on my either side of my or. First thing says track. And the next thing says softball. And then can you be in track and softball? Okay, total is 100. So I'm going to go through and I'm going to write 100 on all of those. Okay, now I'm going to go and find my track. It says 15 students participate in track. So my first number is going to be a 15. Now I'm going to look for my softball. It says 14 participate in softball. So this one's going to be a 14. And then can you be in track and softball? Well, yeah, you can. And then it tells us that 2 participate in both track and softball. So this one is going to be a 2. So if I add 15 plus 14 and I subtract 2, I'm getting 27. If I take 27 and divide it by 100, I get 0.27. And that one just stays that. There's no other numbers, so we can just leave that as our final number. Now I'm going to decide inclusive or exclusive. I have this 2 right there because there's a number in it. It is going to be inclusive. All right, you are set to do the addition rule practice. So when you are done with your notes here, you can go ahead and open those up and get started on those.